Okay. Good morning, students. Today we see about entropy and real process. What is entropy and how it is applicable to the real process? Entropy means measure of molecular disorder. When the molecular disorder means while heating the gas, it will happen. That is, molecular disorder will be measured either by increasing pressure, increasing temperature, like that it will happen. And real life also it is applicable. The unit of entropy is kilojoule by kg Kelvin. Similarly, enthalpy is it is an amount of heat, imaginary heat added to the system during the process. It is also measured in kilojoule by kg Kelvin. And practical process are influenced by irreversibilities. Irreversibility means it may happen due to friction, solid friction, fluid friction, and electrical resistance. Solid friction is an irreversibility. Irreversible machine is the efficiency of an irreversible heat engine will always less than the efficiency of a reversible engine working between same reservoirs. COP, that is coefficient of performance of an irreversible heat pump, will be always less than COP of a reversible heat pump working between the same reservoir. That is, irreversible and irreversible process are between the same reservoir means it doesn't mean that it is working under the same temperature limits. Increase in of entropy principle means that is delta S. Usually we will denote change in entropy delta S. Initial entropy S1, final entropy S2. So delta S is the difference between S1 and del S2. It is the integral of dq by t. Implication of increase of entropy. Entropy, unlike energy, is a non-conservation since it is always increasing. The entropy of a universe is continuously increasing. In other words, it is beginning disrecognized and the approach of chaotic. The entropy generated is due to presence of irreversibilities. Therefore, the higher irreversibilities lead to the higher entropy generation. Second law, entropy balance. Increase of entropy principle is another way of starting the second law of thermodynamics. Second law means entropy can be created but not destroyed. In contrast, the first law states energy is always conserved. Note that this does not mean that the entropy of a system cannot be reduced. It can. However, total energy of a system surrounding cannot be reduced. Entropy of universe. Entropy of a universe means a quantity of heat dq by t is equal to ds. Net entropy is ds equal to dq by t. Third law of thermodynamics means the entropy change of a system during a reversible isothermal process tends towards a zero value, or it is under process. Planck's statement of third law in 1911, Planck one step further and made the hypothesis is that not only does the entropy difference vanish, but Planck's statement of third law, The entropy of every solid or liquid substance is internal equilibrium at absolute zero, itself zero. So in the system itself it is zero. That is third law, that a system to create usable forms of energy sources and characteristics of biosphere is also a form of entropy only. So third law of entropy, it is under the process. And second law of entropy is there. The increase in entropy will happen due to increase in temperature. And irreversibility means, or wastage of energy means, some form or kind of energy will be converted into work. Remaining energy will be supplied to the sink, and the loss in energy may be measured in terms of friction also. So in practical process, irreversibility is fluid friction, solid friction, electrical resistance, thermochemical reaction, unrestricted motion, heat transfer with a finite difference also it happens. So entropy is a measure of molecular disorder. It means either there will be change in the pressure, temperature or volume. So entropy, change in entropy of a gas, either we can measure in the form of pressure and temperature, or relating pressure and temperature, volume and temperature, pressure and temperature. So by relating this, we can find the change in entropy. That's all. Thank you, students. Next lecture we'll see in next class.